This is a steering gearbox out of a 18,000 pound capacity Clark Forklift. Old, obsolete beastie from like the 60s. I took it apart, called all over, took it up to Valley Truck Parts, which was the only place that would even talk to me. Their steering box guy came out from the back room, looked it over, said, yep, he'd seen these before, leave it, they'd see what they could do. Well, they did about what I expected in that this thing is completely obsolete. They talked to some, I don't know who, I think it was Midwest Gear out west who specializes in these things, and they couldn't even get us one because they said, oh yeah, they'd probably get us a used one, whatever. No can do. So I told them if they could just get me a few parts, I'd fix it myself, and they were able to. So they got me a rebuild kit, which is the bearings, seals, all that jazz, and then they were able to get me the crossover tubes. Those had got destroyed. Those are for the recirculating ball screw. But they were able to get me used ones. But that little bag of plunder is $300. I was a little sticker shock, but by golly, we got to have it. So now the plan is tear this down. This shaft is bent right in here because it came all unraveled and was loading the shaft. I've got to straighten the shaft. I'm most likely going to just cold bend it because it's bent past where the bearing surfaces are at. And unless it's got a really ugly bend in it, you're never going to reef on it bad enough with the steering wheel for me to be really that concerned about it being a strength issue. But this nut is all jacked up. Threads are wiped out on it. The interior of this housing is stretched. Threads are also wiped out in there. These threads, strangely, are more intact than those ones are, which I don't quite understand that because the housing is obviously cast iron. And that, I guess, is also cast iron, and it just happens to be softer cast iron. You can see this thing was cast with the idea of having a machined face with a bolt-on end. I've found a few pictures of similar ones online, and that's exactly how they were. So I'm planning to mill the end of this right off from here. Get a few dimensions first, just to give myself an idea where I'm at. But mill the end off, and then drill it and tap it for 4 3/8 bolts. And then we're going to take this nut, and I've decided stick it in the lathe, pick up where that thread is at, and recut those threads at the same pitch, but just reduce the diameter enough to get the threads recut. Wherever the threads clean up at, that's the diameter we'll stop at. And then what I'm going to do is just take, we don't need this particular profile on the outside, so I'm just going to take a square plate of the appropriate thickness and put it in the lathe and bore it and ID thread it to match whatever that nut comes out at. I had thought about doing that before, but I had thought, no, we're not going to do that because I don't want to make it oddball. Well, guess what? We can't get parts for it anyways. So at this point, it don't matter if it's oddball. If I can save that nut, that saves me some machining. Because my original plan had been to make one of those end cap nuts and that plate. But I'm like, well, why go to the extra work? This thing already has the internal dimensions right. You know, the pocket for the bearing, the seal surface. There's no point in reinventing the wheel. And then the other thing that I'll have to do is make an adjusting nut to go with this thing, or a jam nut, because I'm almost certain it originally had one, and I think that might be where the trouble started, is that somewhere along the line somebody left the jam nut off and this thing backed off. But so anyway, that's what we got going on. I will show you guys some progress as we get on it. I got the steering shaft or steering column apart on this thing, and I want to set up to work on these threads, but I want that bearing race out first, so that's what we're setting up to do here in a moment. All right, time to see how this little thing is going to run. This is a machined surface here. I'm hoping it'll run true enough just grabbing that further tinkering isn't needed, but we're going to see here once. I think that's close enough, though. That's my conclusion. All right, we got to find out what the thread pitch is now, get a thread cutting tool, and then we got to see if we can get on this thing. It's going to be a fun little adventure. Yeah, you guys will get to see some interesting stuff before we're through with this. 16 threads per inch. All right. Well, now we know what we're chasing. Let's see here. I gotta find my... I'll bring you guys over and let you admire all this with me. So 16 threads per inch is right there. So I'm in range B. Here's the question, is that it? Or is it the next one over? Let's see here, one. I'm going to say it's the one to the right because we'll come all the way back this direction. Yep, it is. Okay. So I wanted to make sure. Okay, so there's 16 threads per inch. We're on range B. Now, we got to get up here. We got to get this switched over to threads. All right. I believe we are in official thread cutting mode now. All right, let me get set up here and get a tool. Bring you guys in close enough to see the mayhem if it gets ugly. And let's see what happens. All right, we definitely need to go to back gear. Torque was too low and speed was too high. I guess one thing I want to really study here is I do not believe I cut the thread that I intended to cut. I think that's part of the problem here. I think I was screwing threads up instead of cutting them. I needed to be on range C and I was on range B. That's ugly. Alright, we're back in at 0. We're going to try this again at a slower speed. That looks much better. Okay, swing it out half turn, come back. Hear that? That's ugliness happening because they had welded on this thing previously. Yeah, we're following the right thread pitch, but we're going to be cutting a bunch off from her before we get where we're trying to go. Starting to look more like threads though. That part's good. Should be on my final cleanup pass now. And I think we started breaking through the hard. Didn't seem to be destroying the tooling quite as bad and rocking the machine quite as hard. So I'm just taking a few passes here. Without changing any settings, just going back to 0 every time just to let it clean up the thread profile and try and chip my way on through that really obnoxiously hard section. But that is looking a heck of a lot better than what it did. Need a little bit of buffing with a wire wheel just to get the sharp edges off from it, but definitely vast improvement. I think we're going to be ready to go to work on the rest of it next. Alright, so this is the ball screw and steering shaft assembly out of that Clark Forklift steering gearbox made by Saginaw Gear. I think I told you guys that this was bent pretty bad. Well, when I got the part, found out this thing was hollow. Turns out it bends real easy. I grabbed this in the 3-jaw on the lathe, grabbed the end of it by hand and just tweaked it back. So that proved to not be a big deal, but what is a bigger deal here is it's got a bunch of wear in it in here. I'm going to go ahead and weld this thing up a minute. We're going to run the Vevor 200 on it just for the heck of it and see how she does on this kind of project. So I've just got a section in here that needs to get built up and then return. Well, good morning everybody. So And I think I mentioned last video that this thing was a little bit bent here, but it wasn't bad. I was able to just grab this and lathe, tweak it back, because this is just a piece of hollow. But the next problem I ran into is there's a bearing bushing thing that supports this up in the top end of the steering column, and this shaft was just roached right out, rattling, wobbling around in there. So my initial thought was to weld this up and remachine it. I started welding on it. I have never ever had something warp so bad, but I also have to admit I've never tried building up the outside of, you know, a hollow tube this small a diameter, and it was obvious. I mean, I built up all the way around it, threw it in the lathe, you know, and it was sectioned about 4 inches long. 3 inches I was building up, and I'm not kidding. In 3 inches, it warped it 1/8 of an inch. So it became obvious very quickly that that was a total non-starter. So my next thought, and what I did then, is cut about 4 inches out of here, chamfered the ends with the idea that I'd just machine a piece to put in here, and then instead of all this buildup, I'm just running a weld bead around it. But as I got looking at it, this chunk, which is the spline and nut for the steering wheel, is just beat to death. People have been hammering on the end of it. The nut doesn't fit good anymore. And I've decided that I have nothing to lose and everything to gain by just trying to recreate the entire end of this. That eliminates one weld joint, so I've only got one spot to warp when I put it back together. And it lets me cut new threads, and then this is what I'm excited about, is I'm going to attempt to roll this spline onto here. So that's what we're setting up to do here. Let's have at it. All right, so this is a major oddball. It appears to be a 51/64 by 20 thread on there, which I don't even know what that is. 20, I know what it is. 51/64. Never in my life have I run into that as a thread diameter, but clearly some one-off oddball thing that Saginaw thought they ought to do for God only knows what reason. So anyway, I guess we are going to start off by basically roughing this thing out to be this end profile, and then running the threads on it, and then I'm going to go over to the Lodge and Shipley to roll these splines in. I don't want to put that kind of loads on my Monarch. So anyway, I got to go fire up the phase converter and we'll have at her. I think we go ahead and turn it down to the 0.86 diameter once. All right, so I've got my compound set up on 29.5 degrees, and I've got this cool, so this is why I decided to go ahead and do it, is Monarch has this slick adjustable stop here that gives you, what is it, 2.5 revolutions on the dial, and then repeatably stops back in the same spot, specifically for threading. So I've got it set up against the stop there. We're going to come in, get my, use this to feed in for threading, and this should work pretty good. It's what they designed it to do. Because we're cutting an even thread, we should be able to start on any number on the dial. I'm going to just come up here a minute until it just touches the surface. There it is. Okay, now we're going to zero out this dial. We're going to drop it in on 1. So right there is the beauty of that adjustable stop, is it lets me thread without having to have a relief at the end. So now what I want to do is get my thread gauge and make sure we're cutting 20 threads in. Looks good. Alright guys, time to start cutting some threads. So this back into 0. We're going to go plus 10. We can get away with that here. I think this is actually plus 5 on a side. then we're going to drop in on the 2 here once. I think we're going to stop there because I'm a little worried that the nut is slightly jimmied up. I'd rather leave it a bit on the snug side. Like, it'll run on there with a wrench. I'll put a little anti-seize on it. I don't want to risk getting it too loose and having it strip out. Alright guys, well, it's time to go cut ourselves some spline. Not cut, roll ourselves some spline. Alright, so the first thing I need to do here is take this section that's going to get splined and cut it down to the diameter it needs to be for splining. I didn't do that in the Monarch because these, you know, this chuck's got about, last I checked, 3.5 hour run out in it. And I want that surface to be, you know, really true before I start rolling splines. So anyway, I don't care that it might not be absolutely true to the rest of it. A steering wheel is going on here. If it wobbles by 10 thousandths, nobody will be able to tell it or care. So anyway, I gotta cut a section here to get set up for this. So we need to cut over 1/2 inch, and we need to take it down to 840. So I got 20 thou to take off over 1/2 inch of length. Alright, time to change tooling here. Here we have what you may recognize as a plain old-fashioned knurling tool. I cannot give you a bunch of exact science for how this works, why this works. I know there's different pitches, you know, what do they call it? It's, yeah, you got different diametrical pitches, just like you do at gear cutting. At any rate, I went and dug through my knurlers and found one that seemed like it fit the profile of the teeth on the existing spline. And we're going to come in here and start, and that's why you got to get this diameter right, because that's what's going to decide whether you end up with whole teeth or not. At any rate, we're going to come have a swat at it, see what we can do. Results we're getting so far. I'd say that's looking promising. Oh darn, I touched my threads. Boogers. I was getting deflection when I came back out. I'll have to wire wheel them and touch them up a little. That's good for them. Oh well. Alright, I think we're going to back up here. We're going to clean these up a little bit. Can't believe I knurled the top of my thread like that. Ridiculous. We're getting there. Let me go back in here now. It is. Feels a bit snug yet though. Starting to look like a pretty proper spline, guys. Ooh, that's looking like that's it. basically barely left a mark on the top of each of the threads, so not life-threatening. Alright guys, I think that's it. It's time to machine the other end of this thing. Alright, we're shooting for 590. I want a nice tight pilot. We got close to 400 thou to go. I'm going to zero my dial out here. We're going to take 150 and yoink her off there. And we'll take another 150. Good. Okay. Let's go see how that feels. We may be shaving it down a little bit more, but then all this material removal, my intention is to do after we have welded it to that, because if we get any weird run out or anything, I'd like to just machine it in with it from welding if it is. So. Let's go see how this looks. Don't expect it to actually want to go in there right now. As I say, my measuring said the idea of this thing is not actually perfectly round. Feels a little snug though, I think. Need to take at least another 5 off from there. I'm going to hand you the torch. I'm just going to set the torch down. Alright, quick, give me this part. There she is. So you see what we did there, Wiggles? By heating it up, it makes it expand. And then we quick smacked it in there, and now it will have shrunk on there. It'll be like super duper tight when you do that. We put a lot of press fit on it. Now it's shrunk on there. And you probably could get away with almost not welding that at all. It'd be so tight. Alright, we're just going to wire this thing together because I thought about setting up to TIG it, but I haven't got the TIG gear set up right now. And for what this is and what it does, especially with my shrink fit I just did, it's just a question of keeping warpage to a minimum, and I'm pretty confident I can do that this way. Give it a little zap on one side. And just start welding my way around as fast as I can. I think we're going to go get the bit of spatter knocked off here, and then grab this thing in the Monarch and spin it and see how wobbly she is. Alright, well, she's still cooling off, but would you look at that? That thing has just the tiniest wobble in it. I can't even begin to tell you how stoked I am with that. Piloting really did its job on that one. So, now that we've got that covered, I'm going to go ahead and just put a center in here. And we're going to go to work on this thing. Time to come in here and remove some material. So some of what I'm trying to accomplish here is I left it pretty hot and then put it between centers, and I'm quick removing as much of the extra weld as possible. And the hope is that by letting it cool between centers with all the extra material off, that if anything, it'll try to predispose it to finding its correct center. Running true, I guess, would be the right term for that. Hard to measure this swivelly ball because it moves around in there. It can get away from you. Apparently it's smaller than my crummy method of measuring would lead me to believe that it is. It goes over this, which is cut smaller, but then I'm getting stopped dead in my tracks here. All right, well, then we've answered a question. We got more to go. That's it. I can just feel the drag of the machining marks, but that's what we're after right there. Okay, so that said, a little terrifying, but I think this part's about done. I think we're due to go see how some of this fits. So here's the question I haven't been able to check until now. That is, how good or bad is this yet completely? So I might need to go back in the other lathe and roll the spline a little deeper. I just wasn't quite sure where I was at, and I didn't dare keep going. I think we need to clean this spline out real good. Still got a bunch of metal shavings and stuff in it. It's definitely starting on there, I'm just not sure. It's a pretty tight fit the way they originally assemble it. And I definitely am going for a tighter than a looser fit. It's interesting, it's working on there just by me doing that. Well, she's gone on there a fair little ways. Now what I want to do is knock it back off and see if I can tell where it's stuck at. Hoping there'll be some witness marks. But I would say, looks to me like it's going on there about the correct distance as far as where it was relative to the end of the spline. Yeah, I think we're going to leave it just like that. I'd rather have a bit on the snug side than have it too loose, so I think we're just going to call that hunky-dory. Alrighty, so the shaft itself is done. I am just ecstatic with how it came out. We were able to straighten the end where it was bent down there. It had bent, you know, because these bearings were all wobbly loose. Rollers all fell out of them, and it was trying to support the side load of this just off the shaft, and it torqued it. But we were able to straighten that out, build a new end. That's awesome. Now I'll grab this nut. So this nut obviously used to fit in here. I've rechased these threads. It is now substantially smaller than it used to be, but it was already stripped out in there. Combination of this, and as far as I could tell, this had stretched. It was just never fitting in there again anyway. So my plan here is some of these, I don't know which ones and what applications, but I had noticed that it had this, you know, looks like an obvious boss with spots for holes, you know, like you can see, it's clearly designed to be flat and have a plate bolt on the end. And I found some pictures online of some of these Saginaw manual gearboxes. That's exactly how they were. So that's what I'm intending to do with it. We're going to get this thing set up, probably in the saw, cut it off close, and then get this trued up on the mill and deck the top off and drill and tap 4 3/8 holes in there. and then build a plate that bolts on here that I thread internally to match this thing. So that's what we're up to here. I've got to knock out this back bearing and cap a minute, and then we'll be on our merry way. Well, good morning, everybody. We are on to this part of the project now. So I've already thrown this thing in the bandsaw and just amputated a significant chunk of that. I didn't see any point in turning that much iron into black, nasty dust in my shop for no good reason. What I think I'm going to do, I've mulled this overnight. I'm going to see if I can find a pair of shoulder bolts, because I think that's my most accurate method of getting into here. But anyway, try and find a pair of shoulder bolts and see what I can do for squaring up off the edge of those. Now the booger of that is if I use those to square up with, it forces me off the edge of my supporting more. You know, I'd really like this thing fully engaged. How far apart are these suckers? I'm thinking out loud here. So those are 2 3/4 spacing. Yeah, I don't know. I gotta play with it. I'm not really sure what I'm gonna do yet, but I don't love any of my options, though. I guess that's what's really clear here. There's just nothing that I think is a nice option for this. So, but anyway, my thought was if I run shoulder bolts into there, that then I would just slam it up against the edge of my angle plate, you know, squaring that way. And then I can always come back and double check by sweeping this bore, but it would take a whole bunch of the guesswork out of it. But we'll see. And I suppose, I'm just thinking out loud here, I could potentially put my second angle plate up here. You know what? That's what I probably will do, because I'll grab it there. It'll be up on edge, and I could put my other angle plate in from the other side and get clamped on this ear with it, and then I'd be reasonably solid. So, all right, well, that's what we're up to, so we're gonna dig in. All right. Well, let's give you guys a walk around. I believe that is going to be it. So, you ever seen such a convoluted mess before? But we're clamped on that face. We're up against those two dowels, not dowels, but you get the point. Shoulder bolts. Grabbing this ear. I think I'd have to go pretty crazy to push that thing around off them. So I think what we're going to do now is get the coaxial indicator set up and sweep this. I've decided I'm not going to bother with trying to sweep that angle. At this point, I've just realized I'm overthinking this. Like, whatever it is, squared up against those is what it's going to be. The bearings that go on the end of this thing are a annular contact spherical roller bearing, which means they're a self-aligning type bearing that can handle a certain amount of misalignment. And as a result of that, if this thing ends up slightly off, it really is not going to be life or death to it as far as dead square. But I don't know what else I would really square to that I trust any more than I trust those. I mean, that was part of the machining. You can see looking at it, it's obvious those were machined 90 degrees to it. So, and when I deck this off and bolt that cap on, like say if it was off by 2 degrees, the bearings wouldn't care. So at any rate, and the more I've looked at it like that, I'm just not convinced. It's such a sharp angle, you know, and I'm trying to use it to square that I'm just not convinced that my measurements will be believable. So at this point, I think we're just strictly going to sweep the square part of that bore and just get centered on the hole and then deck this thing off and put our 4-bolt pattern in it. So you can see I didn't quite clean up there, but I don't really care. We're just bolting a big flat plate on here, drilling, tapping. I want as much material left in here as I possibly can. So we're going to call it good. We've got enough bearing surface. I'm bolting a 1-inch thick plate onto here. So at any rate, I am looking pretty good here, I think. So now I just have to decide what size bolt pattern we're putting in here and drill and tap it. I can obviously do a little ciphering off from these bosses that are cast in and see, I'm sure I can figure out what size bolt pattern they had in mind and just try and replicate that. So that's what's next. All right, so I did a little measuring, and I would say they originally intended that to be something pretty dumb close to 3 3/8. So we're gonna get this tool out of here, switch over to drill chuck, see what we can do with that. Alright guys, I have decided that I need to do a little bit of parts assembly here now, because I need to start checking on what the overall lengths of some of this stuff is when it's assembled. So I want to make sure that this end cap I build is right. So I think what I'm going to do here in a minute is put the race that goes in here in, because then I can literally set this on here and start getting some idea of where the natural range that this is going to operate in will be. Race. That is very interesting. So, the nose does kind of pilot inside of there a little. This is what I'm wanting to see right here. Just how thick of a plate should I be using? So this says 1 inch, which was what my original guesstimate was. And then I found a piece 1 1/4 inch. I was like, oh, maybe I ought to make it thicker. But no, this is only 1 1/4 inch to the top edge of this right now. And I need some space there for a big locking nut. So I need to make it out of 1 inch. This upgrading it to 1 1/4 inch idea that was rattling around in my goofy head is not an upgrade. It'll just make life impossible, and I'll be cutting it back down. So 1 inch plate it is. Alright, so got my hunk of 1 inch plate roughed out on the saw, and now I've got to square the plate up and then get a hole punched in the middle and get her in the lathe. So anyway, that's what we're up to here now. Well, let's see how we did. So I should measure the crest like that. 4.250, 4.248, so I'm 2 thousandths out of square that direction. 4.250 and 4.250, so pretty darn good. I'm happy with that for what it's doing. I mean, does nothing. All right, well, let's go get ourselves, I gotta think about this. How do I want to do this? Get this thing on a set of parallels, flushed up to one edge of my jaws, and get centered up on it. Then I can use this to pop a hole through the middle and then open it up to, I mean, I'd love to punch a 2-inch hole through there, but I don't think I've got a really convenient way to do that with the mill. Not without getting into boring, and it's not worth all of that. I got faster ways to remove material. If I even get a 1-inch hole through there, though, then what I can do over is I can go over and grab this thing and forge on the lathe, indicate off from that hole, and go to work. So I think some version of that. You know what I could do? Now I'm thinking out loud here. I could pop, say, a 1-inch hole through. I'll do some checking, but I think I've got some reduced shank end mills that might get over 1 inch. And that's what I really need to do, is drop through there with an end mill at the end, because then it'll be, you know, really true. It'll be almost as good as reaming it. And then I'll trust it to indicate off from it when I get over there and put this thing into the lathe. So that's the ticket. Let's see here. I want to get some... Well, let's see here. Curious to see if on size is acceptable or not. What I don't know to start with is how accurate the manufacturer of these studs was. All right, I'm pretty confident I can get it on there. I'm not very confident I can get it back off if I do. So we're gonna go ahead with the rest of our machining and assume that when it goes on, it's gonna be the once and for all kind of go on. But that is the type of fit that I was envisioning. So I just wanted to make sure there wasn't some crazy obstacle to that working. I can see we're shaving a bit of metal, but these grade 8 studs are much tougher than what this is, so they're just kind of shaving the hole a little bit as they go in. But all right, time to go get this in the lathe and really get some work done. Look like a pretty sharp thread now. I might have to knock the top back off from it a bit. So that could be my next problem, is that my minor diameter was actually a little bit too small. It's very possible. I'm basically feeling my way to the end result here. I think what we'll do here, yeah, I'm ending up with too sharp of a thread profile at this point. We're going to do some major cheating here, and we're going to use the threading tool. Sorry, the camera operation's been a little hit and miss. We've had a lot of visitors through the shop this morning. But we are getting them swapped out here now to the 4-jaw so that we can get that end plate in here and get it machined up now. Now we're chip breaking. I don't want to start a total war on here, but I am going to say I was back and forth before I bought this Monarch on whether I wanted a hard-inch HLVH or Monarch 10EE. My uncle is big in the HLVHs. He's got, or had several of them. I don't know how many he has right now. But at any rate, I'm going to tell you, them are not the metal removing machines that a 10EE is. Like, they really are closer to watchmaker's lathe. They're nice lathe, but you don't go doing full-blown heavy-duty machining the way this Monarch will. It's just, they're half or less the weight that this is, way lighter duty. It's a very nice lathe, but they are not a material remover. I think that's where the 10EE really shines, is that it's capable of switching almost seamlessly between precision work and heavy machining work. Alrighty, well, so you can see I went and rounded the corners off and cleaned it up, ran a wire wheel in through the bore and back, and it really, to be honest with you, a little bit of wiggle in it. I think it's fantastic. I don't know that I would have done anything different. So at any rate, we are now going to, I want to get this piece installed on here a minute. I still have a little bit of machine work to do, or I got to cut some notches in here so I can drive that. But what I want to do before that, man, I'm losing my voice, is I want to get this end installed because I want to put Loctite on there. Alrighty, so what I want to do is just put Loctite, or actually sleeve retainer is what I'm using, but I want to put that around this face as a sealer, but then also my intention with that is that it will hopefully also encourage this to not slide around if it gets, I mean, I got it pretty snug on these studs, but something tells me that this is one of those kind of projects that after you've done it once, you don't ever feel the urge to do it again. Right. Well, I've been back and forth all over the shop, forgetting to run the camera, but at any rate, I've got it together, but that nut, I should have had that thing much looser fitting than what it was. The facts are, it was that, you know, this jam nut, it was a royal pain in the butt. I had to shave a little bit out of its minor diameter because it was up here where these hard spots were from the weld. I hadn't got good thread profile and it just didn't want to thread in there nice. But at any rate, it's in there, it's adjusted, it's together, and by golly, we are putting this thing together and getting it done. Well, by golly, that's it. That is one steering gearbox back together and ready to go back into the forklift tomorrow, guys. I don't think I'll bother videoing any of the putting it in, so this will be it for this one. But anyway, what a project. Major modifications, but by golly, yeah. So cut the shaft off, made a whole new end for that, machined the end of the housing off, drilled it, tapped it, built a new end piece to replace it, remachined or rethreaded this adjusting nut, and then machined a new jam nut for it from scratch. So anyway, we'll go put this together tomorrow and they can get back to lifting. So till next time, you guys all have a good one. Good morning, everybody. So it occurred to me that something that sooner or later somebody's guaranteed to want to know is how much time did I have in this and how much did this project cost? So I thought I'd quick put a little tail ender video on here. Let me look this up. I've been kind of keeping track of stuff. All right, so for your watching entertainment, this thing has got, between removing it, I went and pulled it out of the forklift, which was its own little project. I think I had close to 2 hours into getting this thing out of the forklift, and I still have to go put it back in. So we can assume probably not 2 putting it back in, because I didn't know what I was getting in for, and I don't have a service truck anymore, so I had to get inventive with some tools. Now that I know what I need, I'm going to say I'm going to put it back in an hour, because I'm going to take better tools with me. But anyway, so keep that in mind. I had 2 hours pulling it out, and then I had to do all the running for going and getting parts, tracking it down, and I ran, let's see here. I had a good 3 hours worth of running it up to Grand Rapids and coming back. So that said, so we'll knock those 5 hours off. Right now, I'm showing 21 hours into this project. So if we take those 5 off, we've got 16 hours worth of actual working on this thing. You know, like tearing stuff apart, cleaning stuff, making parts, modifying parts, 16 hours. And if I just build through at shop rate, which I think I've told you all before was 120 bucks an hour, I'd have, you know, and honestly, I'm a one-man band. I more and more have tended to just, if I give customers the options of chasing their own parts, and if they have me do it, it's just shop rate, because I'm either not here working and out running around, or I'm back here, you know, working. I used to be a little more flexible that, but it's like, no, I try to convince customers, get your own parts, do your own running, let me do the actual work. But in this instance, they want me to. So anyway, if I was just going to build this job, bill it through, I've got $1,995 in labor into this thing. Parts, $306 for that, just, I mean, unbelievably little rebuild kit. And what's funny is, it didn't even all fit. This bushing is supposed to be the one for here, and it's the wrong size. Thankfully, that one's really very little play. I'm not even sure that, how do I put this, that the play that's in it isn't original to it. So at any rate, and then I had another $18.36 in hardware and another 50 bucks worth of chewed up threading inserts, trying to get all these hard spots gnawed off here and stuff. So anyway, for a grand total of $2,369. And like I told you, I still got to go put it back in. Let's say we figure another hour of that. That would put this thing right at $2,500. Now, the customer that I'm doing this for actually happens to be the same fabricating company and used to be machine shop that I got this boring mill from. The founder, which is 3 generations back, was a friend of my grandfather's. Say our families have known each other for years. They've been very kind to me. They're good people. We're not charging them $2,500 for this. To be honest with you, I haven't even settled on how we're going to deal with it. What I'm going to do is go tell them, here's what I got in this in hard cash, which is $400 that I've gotten this in hard cash, and then just say, what do you guys want to spend on this project? The truth is, I don't know what applications they might use something like this in, but there's a lot of them where, frankly, it would not be worth the amount of work that I've put into this to make it come back to life. And this instance, I don't know if this is or isn't one of those. I don't know what a 16,000 pound capacity Clark Forklift is worth. It's got a Detroit 471. It's good working, running machine, other than the steering gearbox went out. And I would imagine it's $15,000 forklift or something. So I guess if this was the only fix, maybe somebody would do it. But at any rate, so that's what I'm at. Like, if I just build somebody, you brought me this problem and said, Andy, fix this, it's a $2,500 fix. But I can't bring myself to charge them that, so we're not going to. So anyway, that's where it sits at. I would say there's two likely outcomes. They end up doing the whole project, parts and labor, for say $1,000, or doing some horse trading with them, swapping them some tooling or something, and we'll all just kind of wash our hands of the project and be glad that we got it done. So anyways, that's it. You guys have a good one, and catch you next time.